Hello Honors Chemistry and welcome to sections 2.6 through 2.8, where all of these sections are just about the art of problem solving and incorporating obviously the topics from this chapter, which are how to convert between different measuring systems, right, like English and metric, how to convert between different sizes of SI units, right, using our prefixes, which, you know, is a very, very important skill, like we talked about. It's a life skill, right, that you can use for forever, right? Especially if you take a baking, for example, right? Okay, so let's start with the problem-solving strategy outlined in your guys' textbook, right? So part of the reason I love this textbook is I feel like if you make the effort to pay attention to all these example problems, right, you are going to be in a great place, okay? Because the book will always, every time we do math stuff, will always outline the exact way to get from our given to our goal, okay? Always, right? And it will always show you the work, right? How they came up with it. And then it will give you a skill builder that sort of re-emphasizes that exact same process that they just did for you, right? Which means that you are reading it once, right? And then you're going to look at it once, and then you're going to do it yourself once, and then you bring all that to class, right? And do it again, right? So super useful, super helpful. So pay attention, right? The general problem-solving strategy that your book introduces here and we'll use all year, right, is that step one, we sort. And by sort, it just means what is your given, what is your goal, okay? Strategize. So they literally draw a solution map, right? But really, we just need to think, how do we get from the given to the goal, right? And in chemistry, right, the vast majority of the time, all we're doing is figuring out what conversion factors are going to get us from point A to point B, okay? Which is why it's important, right? Here in chapter 2, right, there's no way for you to really grasp what I'm saying here, but this is the foundation for the entire school year, okay? Once you master the art of how to recognize a conversion factor and what to do with it, the vast majority of the year goes quite smoothly once you get that down, okay? So figure out what conversion factors you need to use and how to arrange them appropriately, right? Then you do your actual math, and then the beauty of chemistry is that always check your answer, right? We can reason through, right? Does it make sense? We can look at our units and see, did we set up the math part correctly, right? There are lots of ways for us to check our answer in chemistry, which is an awesome thing. All right, so let's go ahead and do some practice problems together to make sure that we are on the right track. All right, so these are the skill builders from 2.6, 2.7, and 2.8 that we're going to work out together, okay? So this one says that we're going to convert 56 centimeters, so clearly that's our given, right? 2 inches, which is our goal, right? How many inches? So in order to get from centimeters to inches, we need to have a conversion factor to do that, right? And if we think back, right, oh, lo and behold, I know that 2.54 centimeters equals 1 inch. Which hypothetically you have memorized, or almost. So 2.54 centimeters equals 1 inch. Now, that's a relationship, and I can use it any way I need. So then I'm going to always start by writing my given. And then I'm going to put a line, and that's going to divide the pieces of my conversion factor, right? That's sort of like a stand-in for the equal sign, right? Because all of these are just relationships, okay? So if I have centimeters here, and if you like, for organization's sake, you're welcome to put a 1 on top of there, 1 underneath there, right? But if this is centimeters, then I need this bottom unit to say centimeters, okay? Because they need to cancel. 2.54 is what goes with that centimeters. 1 goes with the inch, right? Units and its accompanying value are inseparable, okay? Which means that now if I take a look at this, right, centimeters as a unit cancels. The only unit left is 1. Now I just have to do my math, right? And this is the same thing you guys have been doing for years now, right? Where I would just multiply across the top, which says 56, divide by the bottom, right? 2.54, right? And then I just need to do that math, which gives us 22.047 inches. But then I need to think about significant figures, so I will go back to my given. And so for now, you will always go back to your given, all right? We are going to consider our conversion factor as perfect. They're not all perfect, but for the ease of math, we're going to consider our conversion factor as perfect and always go back to our given. Our given has how many sig figs in this case? Right, it has 3, so we're going to keep 3 digits. That 4 does not round that up, which means my final answer is going to be 22.0 inches. Yes? All right. Next up, we have this many meters, so this is our given. And it says we'd like to convert to kilometers, so this is our goal. is how many kilometers, okay? In order to get from meters to kilometers, right? So note that meters, kilometers, this means we have to use that prefix table, yes? So let's go find that relationship on the prefix table, meters and kilometers. So meters go here, kilometers is here. So that's a relationship of 10 to the 3. Let's just write this out. So I have meters on one side, kilometers on the other side. Which of these is bigger, right? Kilometers, right? 10 to the third is our relationship. So that's the conversion factor I need to take back with me. 10 to the third meters equals 1 kilometer. So 10 to the third meters equals 1 kilometer. Okay. And then now I just put that where I need it. So 5, 6, 7, 8 meters. And again, same setup, right? If I have meters here, I need meters down here. So 10 to the third meters for every 1 kilometer, right? And then when I set that up, what's going to happen is my meters cancel as a unit. Kilometers are all that's left. Now I just have to do the math, right? Which again means multiply across the top, 5, 6, 7, 8 kilometers. And I'm going to divide by what's on the bottom, which is 10 to the third meters, right? Which really means I'm dividing by 1,000, yes? Or I'm getting 3 decimal places smaller, right? Or if we think about it, if we think about scientific notation, right? If I do division of 2 pieces of scientific notation, it'd be like subtracting it. Yes, does that make sense? All this should ring a bell. Either way, we end up with 5.678 kilometers as our final answer. Oh, that cancels out, right? And we go back to our given, which is 4 sig figs. 4 sig figs, we are done. Yes? All right, a recipe calls for 1.2 cups of oil, so this is clearly our given, and we would like to know how many liters of oil this is, so this is clearly our goal, how many liters, right? So if I want to go from cups to liters, clearly this is a difference between our units of measure, right? And then we'd go back to, life things we should know, right? 1 quart is equal to 4 cups, and here's a relationship between cups, quarts, and liters, so let's go ahead and write that out, right? So 1 quart is equal to 4 cups. And I know that, what did that measurement say? 1 liter is equal to 1.057 quarts. 1 liter is 1.057 quarts. Now, obviously, this one is not on the list of memorized conversion factors. So if I gave you this problem, I would supply you with that conversion factor, right? Or odds are I'd give you a handful of conversion factors and you'd have to figure out which ones are useful. All right, so same principle though. I'll start with my given, 1.2 cups. And then my conversion factor now is I need to find one where cups will cancel. So I'm going to use this one. 4 cups goes on the bottom because that needs to cancel. 1 quart will go on the top. My cups cancel and I've converted to quarts. But I'm not done because quarts is not my goal. Liters is my goal. So same principle. Now I'm going to put quarts on the bottom. And then I'll put my 1 liter on top. Then quarts cancel, and liters are all that remain, right? But same principle for the math. I'm going to multiply across my top, which is 1.2, and I'm going to multiply across my bottom, which would be 4 times 1.057, and then I'll do that last piece of math, or however you want to do it. If you don't need to do it stepwise, just type all that in your calculator, and that's fine also, right? The beauty of your calculators is that you can see everything, so you don't need to do it piecewise. You can see all your inputs, right, as you go. Then we'll go back to our given for sig figs. How many sig figs are here? Right, 2, which means this needs to have 2, which means 0.28 liters is our final answer. Yes? Good? All right, now we could just as well have done this last problem in 2 steps, right? So if you don't like putting it all together, that's fine, right? We could do this first and solve, and that would give us how many quarts we have, right? And then we could take that number of quarts and then do that next step, right? And that would be fine also, yes? And you'd see you would get the same thing just in 2 steps, right? Whatever makes sense to you. So as we practice this, I'm going to tend to write it in one long piece of math, right? If you don't like that, come see me and we can talk about how to set it up differently for you, right? In the small pieces. Okay. More. A running track measures 1,056 feet per lap. What does that really mean? Right, that is in and of itself a conversion factor, right? It's telling you that 1056 feet are equal to 1 lap. And if that many feet are equal to 1 lap, then that is not your given, right? That's a conversion factor that we're going to use at some point during this problem. Now it says to run 15 kilometers, this is our given. how many laps, right? This is our goal, right? Is number of laps should you run, okay? So here I have a relationship between laps and feet. Here I have a relationship between miles and feet. So I think we're good to go. Okay, so we'll go ahead and get started, right? So we have our 15 kilometers. But we'll see that neither of those conversion factors we have contains kilometers. So do we know the relationship between kilometers and either feet or lap or miles? Yes, because you've memorized, hypothetically, the relationship between kilometers and miles, yes? As in, 1 kilometer is equal to 0.6214 miles. So let's fill that in, right? 1 kilometer is equal to 0.6214 miles. Because we need the kilometers to cancel, that's where each piece needs to go. Now I need miles to cancel, so now we'll incorporate this, where it says 1 mile is equal to 5,280 feet. Miles cancels. Now I'm at feet. Now I will incorporate that last one, which says 1056 feet is equal to 1 lap. Feet cancels. Laps are the only unit left. I will multiply across the numerators, divide by the denominators, right? And we get 46.605 laps. And we'll round to the right number of sig figs, which is 3, right? So I need to do 46.6 laps around this particular track in order to run my 15 kilometers, right? Good? All right. So an island is this many nautical miles from the coast. How far away is the island in meters? So here is our goal. Right, we would like to know how many meters from this many nautical miles, right? And it turns out, oh, look, I know the relationship between nautical miles and normal miles. And do I know the relationship between miles and meters? Oh my gosh, yes, I do. Basically, I do. We'll get there in a second. So let's start from our given, 5.72 nautical miles. Okay, and then we're going to incorporate this where, again, what needs to cancel will cancel. So 1 nautical mile, 1.151 miles. All right, so nautical miles cancel, and now I'm at normal miles. Now, what's the relationship between miles and meters? Oh, well, you've not memorized that one, but that's okay, because we already know the relationship between that. So 0.6214 miles is equal to 1 kilometer. And then do I know the relationship between kilometers and meters? Absolutely, right? Which one of these is bigger? Right, kilometers is bigger, is equal to 10 to the third meters. Yes? So 1 kilometer, 10 to the third meters. Meters are all that remains. We would multiply across the numerators and then divide by the denominators. So lots of meters. And we would go back to here for our sig fig. So 1, 2, 3. So 10600 meters. Yes? Now here it's important, right? You might be tempted to say, oh, 3 sig figs, so 106, and then put meter on the end, right? But note that here, that's not okay, right? 106 is 3 sig figs, but it's not the right size value, yes? The right size is 10,000-ish, not 100-ish. Yes, does that make sense, right? So we need to put 2 place-holding zeros at the end that don't count as significant figures, but give us the right sized value, okay? And then finally, we have a car is driving at a velocity of 65 kilometers per hour, and I would like to convert that velocity to meters per second, okay? So 65 kilometers per hour, and you can start in whichever direction makes most sense to you. We're going to convert our meters, so our distance units are going to go from meters to kilometers, right? And we already know that relationship, so 1 kilometer is equal to 10 to the third meters. Kilometers cancel, okay? Now we've got to convert our hours into seconds. So, if we think about what that means, we have hour down here, which means hour needs to go up here. And do you know the relationship between hours and seconds? Well, most of us know that 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds, right? So you'll see that hours cancel, minutes cancel, and then if we look at our units carefully, right, we will see that now we have meters on the top, seconds on the bottom, which is exactly what we were looking for. So now it's just a matter of doing the math correctly, right? 18.055 repeating meters per second. And then we just need to round to 2 sig figs, so 18. All right, makes sense? Okay, so no worries, you will do lots and lots of practice and it will become second nature. And, right, I may not feel like it right now, but all of this also gets easier once the memorized conversion factors are actually memorized, right? Once you don't have to also process what the conversion factor is, then the actual math part gets easier, right? So do make sure that's something you are devoting some time to, all right? Thank you for listening, be good, and I will see you soon. Bye.